Welcome all, welcome to this lab of Object-Oriented Programming 1. Today we'll continue with our Java programs and we'll try to finish the list of programs today itself. Let me show the disclaimer, then I'll start the session. Okay, so let's continue now, and in our programming list, we have seen up to program number 22. So now today we'll start with program number 23 and then we'll see 24 and 25. Okay, so what is program number 23? It says write a generic method that returns minimum elements in a two-dimensional array. Okay, so let's see the program. Check this out. This is program number 23 where we have basically two methods. One is main method and another is a main method. What does it say? It says that write a generic method that returns the minimum elements in a two-dimensional array. Okay, so we need the minimum number from a two-dimensional array list. Okay, only array, not even array list. So check this out. This is the method, and basically the method name is min. Okay, and so this is method name. Then we have this two-dimensional array as a parameter to this particular method. Okay, it's a static method, publicly available method. Okay, static, so that it can be directly called inside the main method. Okay, and what does it return? See, this is return type. This is what? This is nothing but the return type. Okay, and so this also is a part of that return type. E is the return type. Okay. So now, what does this E specify? Okay. So this E, it basically, you can see that it extends, E extends comparable interface and of comparable of type E. That's what we have defined over here. And then we are specifying E. Okay. And E is also specified over here. So what does this E mean? Let's see that. Okay. So in main method, check this out. We have an array of integers, two-dimensional array of integers. You can see that it's a 10 by 10 matrix. Okay. And this integer array would be populated with some values. So we start with value equal to 0. And then inside this loop, what do we do is, we start from I equal to 0 to list.length. What is list.length? List.length means, see, if this is an array, it's a 10 by 10 array, right? Okay, so check this out. This is a kind of 10 by 10 array that you are passing. Oh, sorry. So see, this 10 by 10 array is nothing but the list array. Okay. So when you say list dot length, it means it is equivalent to saying list of 0 dot length. Okay. It's equivalent to saying list of 0 dot length. Understand? Just a minute. Okay, so here we have a 10 by 10 array. Okay, and that array will be populated with some value. What will be the value? Value will be incremented with each iteration. So you can see over here that in this loop we start from 0 to list dot length, which is nothing but the length of the basically it represents the number of rows. Okay, so if you have a 10 by 10 matrix like this, suppose a 10 by 10 matrix is like this over here, right? So in this 10 by 10 matrix, when we say list dot length, it represents the length of this uh, particular thing. So you can say that number of rows would be represented by this particular uh, length. Okay, so that is nothing but the rows would be starting from 0 to would go up to 9, and here also the number of columns would go from 0 up to 9, right? When we say list dot length, that refers to this particular length. When we say list of I dot length, okay, what would be I? I may start from 0 up to 9. I may go, I would go from 0 up to 9. And if you say J, what is J? J is the index of the columns. So they would go from also 0 to 9. So I goes from 0 up to the length of I up to I less than the length of the list. So 0 to 9, and J also starts from 0 and goes up to the length of ith list. If this is the ith list, 0 is the ith list, so the length of this particular list. If I is equal to 1, then the length of this particular list. If I is equal to 9, then the length of this particular list. Okay, in this way. So what is the length of each list? Length of this list is 9, length of this list is also 9, length of this particular list is also 9. So the inner loop also will go from 0 to 9. In fact 10, the length is 10, so it will go from 0 to 9, and the outer loop also goes from 0 to 9. So the outer loop is this one, and the inner loop is this one. Okay, outer loop iterates over the what? Outer loop iterates over the number of rows, and the inner loop iterates over the what number of columns. Okay. In all, we are accessing each and every cell of this particular list, and to each cell we are assigning a value. What is the value? Value starts from 0, but we start incrementing it and then start assigning it. You can see we are incrementing this value and then that is being assigned. So it starts from 1, 2, 3 up to, it will go up to 100. Okay. So this element would be something like this. It will be like this element will have 1, and this element would have 2, then this element would have about number 10. Okay. And similarly, this element would have number 100. Okay. In this way, this particular code will populate this list. Will do what? It will populate this particular list. Okay. This does what? Populates the two-dimensional list array. Okay. Populates with some values. And then we call this min method, where we pass this list, which is nothing but a two-dimensional integer array. Okay. Now, why we are passing integer array and not int array? Because here we require what? Here we require basically the here we require the list of generic data type. Okay. This E represents what? This E represents the generic data type. Okay. So we need an array of generic data type. So this list here represents array of generic data type. Okay. And so generic means this generic can have any class type. Means any class type. Generic means any class type. Okay. But obviously it should be a class data type and not a primitive data type. It should be a data type for object, that is class. It should not be a data type of primitive variable. Okay. So that's why here we are taking the array of two-dimensional array of integer wrapper object type, not the int, because int is a primitive data type which cannot be represented by a generic data type. Generic data type can only represent any class type, any of the class type, but not primitive data type. As simple as that. Now check this out. In this mean method, we take that particular two-dimensional array, and what do we do is check this out. We first get the 0th element. Okay, we first get that 0th element. Now we don't know what is the type of this list or this particular element, 0th element. So that 0th element is nothing but basically check this out, this element. Is out. This is the matrix. When we say list of 0, 0, that represents this particular element. So if any number is there, suppose here the number was 1, so that 1 goes to this min type, min variable, which is of type E. Now what is the type E over here? Here it will be of integer wrapper type. This type E is of type integer. Okay. And the value that we are assigning to it, that is this particular value, okay, this value is also of type integer. So there is no worry. Okay. And once we have that first element, we take that element as the minimum element. And then we start the loop, which goes for, check this out, it goes for like this, for E of list, E of elements inside the list. So whatever the elements are there, which is of type an array of E type, which is integer type, all the elements inside the list will be iterated, and inside that each list, what do inside that each element, you use the for loop, and you say for each element inside this elements. Okay, for each element inside this elements. What is this elements? Elements is nothing but one dimensional array, and this element is the actual element from that one dimensional array. So each two-dimensional, from this two-dimensional array, this particular array, one single array, will represent by this elements. It will be represented by elements. Okay. And when you say element, a single element will be represented by it. Understand? E, see Harshit, E is not a class. E represents the generic data type, which can be replaced by any class type. Okay. So see, here E is not extending itself. E is extending a comparable interface of type E. Here basically we are not implementing it, but what we are doing is we are making use of this E. Now see, this min method can also be used, since it's a generic method, it can also be used to find the minimum value from an maybe float data, a float array. This is integer array, we can even use float array or a double array. Okay. So what does this, first understand what does this method do? This method first takes the first element of the two-dimensional array as the minimum, then it iterates over the whole two-dimensional array and it compares. It says element dot compare to mean. Now this compare to method is basically used over here because this element is of type E, which extends comparable interface. Comparing objects of type E. Comparable interface basically has this compare to method. Comparable interface has compare to method. Okay. So this E class, whatever E class would be there, that would be extending the comparable class that will be able to have compare to method for any E type. So it should be able to compare the same kind of objects. Okay. So comparable interface provides this compare to method. So here we are using it. Here we are making use of this comparable interface. The comparable basically type. So comparable is an interface, okay, and it implements this compare to method. So here what do we say? E extends comparable of type E. So it automatically sorry for that. So automatically what happens is automatically we say E extends comparable of E, and automatically this implements the compare to method which is already implemented inside the integer class. Okay, and it says element dot compare to minimum. If this is less than 0, it means the element number that you got from this for loop in that iteration of for loop, that element number is less than this min number. If it is greater than 0, it means element number is greater than this minimum number. So what do we say? If element number is less than 0, if element dot compare to this minimum, if the result of that comparing is less than 0, it means element is less than minimum. So we say min equal to element. So assign that element to minimum value. Okay. And so in this way we get the minimum element. We iterate over the whole for loop. We iterate over the whole two-dimensional array using two for loops. First for loop is for rows, second for loop is for columns. And in the first for loop, what do we say? We say E of elements in list. What is list? List is a two-dimensional array out of which we are accessing a single dimensional array. Okay. And then again we are using for loop to iterate over the columns, and we say E of element in that elements array. So that elements array has a single dimensional array, and from that we are taking each element, and then we are comparing that each element to minimum value. And if the value of that is less than 0, then we say minimum equal to 1. We can even say something like this. See, if element is less than min, then you do what? Then you say min equal to element. Assign the value of element to min. That's it. This is what we can say instead of this. So this can be replaced by this. This thing can be replaced by this part. Understand? This code and this code is almost same. Why I say almost same? Because here we are directly comparing the element to min, and if so, this could return true or false. Whereas here what we are doing is, here we are exactly comparing it and getting the value whether element is less than minimum. So if it's something like this, when you say that this compare to this returns, when this returns -1, it means what? It means that element is less than min. If it returns 0, then we say element is same as min. And if it returns +1, then we say element is greater than min. Understand? If this returns 0, if this returns 1. So this is a good comparison way. This is a good way to compare. Okay. And since here we are implementing a E type, which is a generic type, which also extends comparable of E type. So it automatically implements this comparative method. And for wrapper classes, this is automatically given. If it would have been your own class, then you would have to implement this comparable interface, implement this comparative method in your code, and provide some code for this. Whereas since this is an what? This is an wrapper class, this implementation is automatically provided. Wrapper class provides that. So you don't need to worry about it. You don't need to worry how this comparative method will be implemented. Understand? Is this thing clear, Harshit? So here everywhere E represents generic type. Whatever type of data that you pass over here, whatever type of array that you pass over here, that will be get replaced by this E. And so at compile time, this E will be replaced by all this integer value. Integer data type will be put over here in place of E. It's as simple as that. Okay. So now see, let me show you how it runs. Obviously, it will represent the minimum value as 1. Here we say, see, minimum is equal to 1. Now, if we change this thing, if we say element.compare to is greater than 0, then use a min equal to element. So this will now not become maximum element, not min element. I just change the sign from less than to greater than. And now if I run this, so it says minimum equal to 100. You see that? So it gives us the maximum value, not the minimum value. 100 is the last value because there are 10 into 10, there is 100 elements and we are starting for incrementing 1 to up to 100, right? So 100 is the maximum value. Understand? So if we just reverse this sign, this whole method's operation will change from minimum to maximum. Okay. Now let me show you if we have what if we have instead of integer, suppose now we have double data type. Okay, a double list, 2-dimensional double list, and let's say we have 2 by 2 matrix of double data type. Okay, and we'll say this as B list. So we call it as what? B list. Now, what do? We use the same kind of for loop, and here instead of list we will use D list. That's it. And instead of this value, what we will do is we'll assign a double p value equal to 0.0. Okay. So here we will give the p value. So here we are assigning what? Here we are populating the array double, which is a 2-dimensional array with a d value. And then we can say, here we will say minimum integer, and here we will say min double. Okay. Min integer and min double. Right. Now let's run this. Let's okay. Now we have to, and see the min method is same method is there, and here we will be passing d list. As simple as that. Here we are passing list. Here we are passing d list. So here we are passing array of integer data type, two-dimensional array of integer data type. Here we are passing an integer array of, sorry, double array of two-dimensional data type. Okay, two-dimensional double array, and here two-dimensional integer array is being passed. Okay, this is two-dimensional integer array. This is what? Two-dimensional double array, and both are being passed to this same main method. Both are being passed to this main method in each call. This call passes the integer array, two-dimensional integer array. This call passes the two-dimensional double array. So you can see this E means generate data type. It represents any class type. So any class, two-dimensional array of any class type can be sent over here. It's as simple as that. So let's run this out and check. Check this out. Minimum integer is 1, minimum double is 1. We started with 1, right? Even suppose if we give this D value to be 100, okay, and then we, instead of increasing this D value, we start decreasing it. Then also we'll get the minimum as 1. Okay, so min double is 96. 96 has been assigned. Okay, so I think there is some issue. D value minus minus. Let us just display it out. Let us try to display this out. So we'll come to know what is happening. Let us just display it out over here only. Okay. Let's take it as 2. Okay, sorry, we are having 2 by 2 only. No, that's why. That's the problem. Okay. Let's take it as 10 by 10. So now we don't need to worry about this. That's it. Our size was wrong. Now this will also give us minimum value as 1.0 or 0.0. Yes, 0.0. See that? So here we have to start from 1.0 or let's say 0.0, and we start incrementing it, and then we will get only 1.0. That's it. So you see the difference. I can send an integer array also, two-dimensional array also, or double type two-dimensional array also. Now if I have any other wrapper data types two-dimensional array, I can pass that also. It's as simple as that. Okay. Got the point? Yes, sir. So that was right. It was 2 by 2. That's why. Okay. So that is our practical number 23. Now let's open number 24. What does this 24 practical number 24 say? 24 says Define my priority queue class that extends priority queue to implement the clonable interface and implement the clone method to clone a priority queue. So we have to basically do we have to create a my priority queue class that will extend the priority queue and also implement the clonable interface. Clonable interface provides this clone method which we need to implement. Okay, so let's see that. This is practical number 24. So check this out. Here we have this main method and we also have this class which has been created inside our this main class. Practical 24 number class. Okay. So check this out. This is a static class which extends priority queue and implements clonable. You see that? This particular my priority queue. Now see queue should have objects of some type. Okay. So what we are defining here is we are defining that the queue will be of type E, that is generic. Any data type, any class type can be used to create this my priority queue class. And it also extends priority queue of type what? Of type generic. So any class type can be used to create this priority queue. And it also implements clonable. Let's see what is there inside this class. See, in this clonable method is there. So we are overriding it and we say public object clone throws clone not supported exception. So this is the method signature that is provided by this clonable and we have to override it. So we say at the rate override annotation. We say that this method is now overriding the method that comes from this and also from this. If there is a clone method implemented in this, then that also will be overridden, and obviously the one that is provided inside the clonable interface, that is obviously being overridden. This is the clone method signature where what do? We are implementing our code over here. So we say new priority queue, my priority queue E of type of variable clone, or we can say variable clone of type my priority queue E as a new priority queue object. And now then we say these dot for each clone offers. What is this represents? This represents the object of this particular class. Okay, inside that we use this for each method. For each clone, you offer. See, this is something like this. Check this out. This for each does what? It has got a consumer of type action. It performs the given action for each element of the iterable unit. So this and all elements have been processed or action throws an exception. Until the exception is thrown over all elements have been processed, then this performs a given action for each element. So for each does what? For each performs some action. Parameter is in action. Okay, and what is the action? Action is offer action. Okay, action is offer action. Offer action is nothing but to make the clone of that particular object. Okay. What is this offer action? Check this out. This is the offer action. Okay. And it inserts the specified element into this queue if it is possible to do so immediately without violating capacity restrictions. So basically that adds it to the queue. As simple as that. A clone object is added to the queue. And then we say return clone. What is clone? The whole clone object. So see, First we create as an empty my priority queue object, and then we say this dot for each. What is this? Now see here, this represents basically not this particular class, but the covering class. Okay, and inside that we say for each clone offer it. Offer it means add it to the what? Add it to the my priority queue clone object. Okay, and then we return the clone object. So see, check this out. Here, what we do? Here we create a my priority queue of type string. Okay. Okay. Now see this notation. Here we are saying my priority queue of type string. So here you don't need to specify the string type. That is allowed. This thing is allowed. Okay. Omitting the generic type while creating the object, because you have already specified it by declaration, is allowed. Okay. So it's okay if you don't specify that this string type over here. It will automatically create a my priority queue object of type string only. Then what do we do? So check this out. We say queue dot offer 1, 2, and 3. So this offer adds what? Offer does what? This inserts the specified element into the priority queue. Whatever element you have specified will be inserted inside this priority queue object, and it can throw a class cast exception and a pointer exception. So first we are creating a my priority key of type string, and then we are adding 3 strings to it. Okay. Offer method basically adds the string or the object into the priority queue. And then we say, check this out, we say another q1, okay, and we say q1 is equal to q dot clone. What is this q dot clone going to do? It goes to this q dot clone method call, goes to this clone method, and it returns what? It returns a clone object. So that clone object will be assigned to this q1 after being cast into my priority queue of type string. Okay. Since it is just returning an object type, that object type has to be cast into this my priority queue of type string. Understand what we are doing? See, here we are saying okay, check this out. Here we are saying that this is the my priority queue q1, and q1 is equal to q dot clone. So what this will do is this will take the control to this clone method, right? Will take the control to this clone method, and here it creates a new priority key object, and then say this dot for each. This means what? The object that invoked this method. Which object invoked? Q object invoked. What was there inside the Q object? String 1, string 2, and string 3. This was the priority queue object. Right? So when we say Q dot clone, it will say that this dot for each clone offer. So for each object you offer that to what? When you say clone colon offer means for each object inside this queue, add it to this clone. So one by one what happens is, one by one, this 1 gets added to the queue, this 2 gets added to the queue, and this 3 gets added to the queue. Understand? This is element 1, this is element 2 and element 3. So what happens? Each time, each element gets added to this particular queue. This element gets added over here, this element gets added over here, this element gets added over here. As simple as that. And that is nothing but this flow. So one gets added over here, one gets added over here, and 2 gets added over here, and then this 3 gets added over here. Okay, and then this clone gets returned. Clone object gets returned. Okay. So this is how basically you clone a priority queue. Doing what? You are implementing the clone method. Okay. Implementing the clone method. So that was our practical number 24. Okay. Okay guys, so let's now continue with the last program. Let me just display it out. So the last program is program number 25. It says write a program that reads word from a text file and displays all the non-duplicate words in descending order. The text file is passed as a command line argument. Okay. So let us open practical number 25. Check this out. This is a very simple program. Here only what we are doing is here we are using a collection class. Okay. So check this out. This is the main method where we check first if arguments dot length is equal to 1, which means if there is one argument passed, then only you continue with this code. So it starts from here to here. Else we say please pass the file name as command line argument. Okay. So once we have passed a command line argument as a file name, then we take that as a string, and then check this out. We say we also create a string, a tree set object called set. We say new tree set. It is of type string. So this tree set collection object will have a collection of strings. Okay. And so that is basically what a simple object of T set. Okay. Now see, we then create the file from that file name. Okay, we create the file from the object. Dot has next file, since if as has got next object, then you add that to the, you get that next object and you add it to the what, you add it to the set of tree. Now this tree set basically has what, if you see the tree set class, this tree set class basically it is something like this. See, there is this iterable, right? This is iterable interface, which is extended by collection interface, which is extended by the set interface, which is extended by the sorted set interface. Okay. And in the end it is implemented, the sorted set is implemented by tree set class. The implementation is something like this, represented by dotted array or dashed array, we can say. Like this. Okay. So all these are being extended. This is being extended by collection. Set extends the collection. Sorted set extends set, and tree set then implements the sorted set. Now what is tree set class? It implements the set interface that uses a tree for storage. Okay. Okay, there is one more class in between this that we need, and that is basically navigable set. Forgot that. It's navigable set, extends sorted set, and then you have the tree set. It actually implements this navigable set. It's like that. So all these are extends. Here it is extends. Here also extends. Here also extends. Here also extends, and here it is implements. Like that. Okay, so this is how the tree set hierarchy is. Okay, so this is the whole hierarchy of tree set class. Okay, what is tree set class? It implements the set interface that uses a tree for storage, and so it inherits abstract set class and also implements navigable set interface. So tree set class are stored, basically objects in the tree set class are stored in ascending order, so they are automatically sorted, and since it's a set, it does not allow duplicate elements. Since it's a set, it does what? It does not allow duplicate elements, so it automatically sorts the elements that are added into it, and also does not allow duplicate elements to be added. So tree set contains unique elements only, like hash set, and tree set can access much faster way, and it does not allow null elements to be added. Okay, and it maintains the ascending order of the objects. So objects are basically compared to each other, and then they are automatically sorted into the set. Okay. So see what happens is, once we start adding, when we say s.next, that will do what? That will use the scanner object to read the next line from the file, from this particular file, right? And it will start adding that particular object to this set. So suppose the file has got something like this: ABC, 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 again ABC, again ABC. See, if you see how many unique elements are there, this is unique, this is unique, this one is unique, and again this one is unique. These two are not. This is already there, this is already there, right? So what happens is, these 4 units get added to the tree set, and then we print it out. We will see what is there inside the set. So let's create one file over here first. Here we will create one file saying list.txt. Inside we put the list. So it's ABC, 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 and then again we put ABC, again we put ABC, Again we put ABC, ABC, and ABC in capital, and also ABC. Again we put its capital. So see, this one is unique. How many are unique? Check this out. Yes. How many are unique? This one is unique. This one is unique. This one is unique. This one is also unique. And then all are repetitions. All are totally repetitions. Let's add one more, A, B, and C, like this. Okay. So this one is unique. So 1, 2, 3, 4. Okay. And 5 are unique out of this 12. Okay. So let me close this. Now I will have to pass this as a command line argument. So right now, see, we just directly run the program. So it says pass the file as command line argument. So what I will do is, check this out. I will again use this program. And here I will say list.txt. Okay, it cannot find the specified file. So here, what do we say? Okay. So why it does not find is because we have to define the class path as the current directory. So we say set class path equal to dot. Then let's try this out. Okay. Okay. So it is not able to find the specified file. No problem. Let's do one thing. Instead of passing this argument, what we will do is, let's pass that file name over here directly. What we will say is, here we will say string file name is equal to list.txt. Now let's say that this runs or not. Okay, so I think it is finding the file in some other directory location. Let's do one thing. Let's put this file. Let's copy this file from here to, we'll take it to this PC and C drive. Here we will put it. Here we will add it. So we have added it to C drive. Now let's see whether we are able to get it or not. We'll provide full path over here, C/txt. Now let's run it out. There it is. You see that? This is the list of elements inside the tree set. ABC, 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 and ABC. So here all capital, here only A capital and C capital, here only A capital, here only B capital, and here no capital. See that? So 5 elements are unique which have been added to the tree set. You see that? Yes. So what happens is that now here, instead of passing it as command line argument, we are simply giving it, since there was some issue reading the file from the specified path. We can even give this whole thing as command line argument, whole path as command line argument. So let me use it as a path, as a file name over here. Let's see whether that works or not. Here I'll pass what? I'll pass C colon slash s list dot txt. So fine. So here we have what? Let's use it as the file name over here only instead of this. And here we'll say string file name is equal to C colon slash slash list dot txt. As simple as that. So if we now run this, we will be able to find the list values. That's it. So understand what is happening? We are reading the file, okay, creating a tree set object, and then we are reading one by one each line of that file and adding it to the tree set. So tree set adds only unique values, and it automatically sorts also them. It sorts them out. Okay. So that's the best part. Fine. So that completes our practical number 25. Okay. What I would suggest is you try to convert this program in such a way that it can access the command line argument. Maybe there is some path issue which is according to which it is not able to currently access the file. Okay, so try to convert it into such a program which can read from a specified path, a file from a specified path, and then it can accordingly read elements from that file, and then it can add it to the set. Okay, Ashit is asking, do generic implement iterable interface? See, generic class is the one that can be any class. So it depends on the class whether that implements the iterable interface or not. Okay. Arthur is asking, this is practical from which unit? So basically this practical is a combination of collection and files. So we'll be, don't worry, collections will be taking in our theory also in this week. So you don't worry about that. Okay. There are lots of collection classes that we will be seeing in this week. Okay. So that completes our practical number 25, and that completes our practical list. So what I would expect is that you people run all these practicals and try to implement it in your own way, and also try to create your own PDF file where you have your own implementations of these programs. Okay. So if at all any doubt, please do let me know. I will stop the recording now and we can have an interaction. Okay.